Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Quick fact to grab you. On last year's GCSE Higher papers, transformation questions were responsible for more lost marks than almost any other single topic. Students know the words, but they trip on the signs and the order of moves. If that sounds familiar, stick with me for the next 12 minutes. I'll make this straightforward.
By the end of this episode, you will have 3 things: clear rules for each type of transformation, a worked example you can sketch under time pressure, and a 15-second check to catch sign mistakes. Let's start with the basics. No jargon, just rules you can apply straight away.
First up, vertical versus horizontal shifts. Say you know y equals f of x. If the equation becomes y equals f of x plus a, that plus a is outside the function. It moves the whole graph up. So y equals f of x plus 3 moves everything up by 3 units. Simple visual. Every point on the graph gains 3 in the y direction. Now, horizontal shifts look similar, but they behave the opposite way in sign. If you see y equals f of x plus a, but the plus a is inside the parentheses, like y equals f of x plus 2, that moves the graph left by 2. I know it's a little annoying that a plus moves left, but the rule is changes inside f of x move horizontally, and the sign flips direction. Remember, inside affects x, outside affects y. Curious. So just to check, y equals f of x minus 4 moves right 4, and y equals f of x minus 4 moves down 4. Exactly right, Sam. Y equals f of x minus 4 shifts right by 4, and y equals f of x minus 4 outside shifts down by 4. Let that sink in. It's one of those small things that costs marks when you get it wrong.
Next, stretches and compressions. If you multiply the whole function by a constant k, like y equals k times f of x, that stretches or compresses vertically. If k is greater than 1, the graph is stretched away from the x-axis. If 0 less than k less than 1, it compresses towards the x-axis. Put plainly, multiply everything in y by k, and your y values scale by k.
Contrast that with y equals f of kx. Here the k is inside the function, and it affects the x values. If k is 2, then every x in the original graph needs to be halved to reach the same y, so the graph is compressed horizontally by factor 2. If 0.5, it stretches horizontally. A good quick rule: inside scales the x direction, outside scales the y direction. Keep that phrase in your head. I always mix up inside and outside. Can you show a method that keeps it straight when sketching?
Yes. Use 3 anchor points. Pick 3 easy x values from the original graph. For a cubic, maybe x equals minus 1, 0, 1. Calculate their original y values, then track how each transformation changes those 3 points. If you do that in the same order every time, you avoid sign and order mistakes. We'll use that in the worked example next.
Quick note on reflections. A negative sign outside, y equals minus f of x, flips the graph in the x-axis. Positive y becomes negative. A negative sign inside, y equals f of minus x, flips across the y-axis. Reflections reverse one coordinate sign. Mark it clearly when you track your anchor points.
Time for a worked example. Same anchor point method. Start with y equals f of x, where f is a cubic passing through points minus 1, minus 8, 0, 0, and 1, 2. Now the exam gives y equals minus 2 f of x plus 3 minus 1. We'll apply transformations in the standard algebraic order. First inside changes to x, then the reflection or horizontal scale inside, then outside scale, then outside shift. But crucially, for sketching, track the 3 points through each operation one at a time.
Step 1. Inside we have x plus 3. That means shift left by 3. So our anchor x values move. -1 becomes -4. 0 becomes -3. 1 becomes -2. The y values at this stage are still the original y values, -8, 0 and 2.
Step 2. -2 outside means two things. The minus reflects in the x-axis and the 2 stretches vertically by factor 2. So multiply each y by -2. Our y values become -8 times -2 is +16. 0 stays 0, and 2 times -2 is -4. So the three transformed points are now -4, 16, -3, 0, and -2, -4.
Step 3. Outside we also have -1, so subtract 1 from every y. That gives final points -4, 15, -3, -1, and -2, -5. Plot those 3 points, draw the cubic shape through them, label the coordinates clearly, and you'll have a precise sketch. Write the intermediate steps. Examiners love to see how you track the points.
So, if I write the 3 intermediate y values and show the multiplication and subtraction, that's good enough for method marks.
Exactly. Now let's talk marks, what the examiner wants to see. For a sketch question worth 3 marks, you typically get M1 for a correct setup showing transformations or equations for the new coordinates, M1 for applying the method correctly to at least 2 points, and A1 for the accurate final sketch or labelled coordinates. If you write the 3 original points and then show each algebraic step to get the new 3 points, you're very likely to pick up both method marks even if your sketch is slightly off.
Common marking traps. Students sometimes do the stretch and reflect in the wrong order, or they forget to apply the outside shift after scaling. The easiest way to avoid that is to write each intermediate step on the page. X to x plus 3, y to 2y, y to y minus 1. Even if you don't finish, that written method can buy you marks. Write it down. Don't just think it.
Right. Now the quick win you can use in practice and in the exam. It takes about 15 seconds. Pick a test x. I like x equals 0. Substitute it into the transformed rule and check the y value against your sketch. For our example, x equals 0 became x dashed equals 0 plus 3 equals 3 inside. So find f of 3 on the original graph or estimate from your anchor points. Then apply outside scale and shift. If your plotted y doesn't match the substitution result, you've caught a sign or scale error before you hand it in. Don't skip the check.
That sounds tiny, but I can see how it saves marks. I'll use x equals 0 as my go-to test.
Exactly. Tiny habit, big impact. Final pointers before we go. Always label transformed coordinates, show the algebraic step at each transformation, and use 3 anchor points so your sketch has shape, not just points. Marks are there for the taking if you make the examiner's job easy. Marks are there for the taking.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. The show notes include a downloadable 1-page transformation checklist and 3 worked examples you can print and practice. Stay curious.
Thanks. I'll grab the checklist and practice tracking 3 points every time. Nail this and you're halfway there.